Jai Hind to all. My name is Aarti Chaudhary. So today in today's session we will go for a unit 2, that is of computer network, that is a data link layer. In the data link layer, what we have to do is it's the second layer of the computer network. In the first layer, that is a physical layer, and that is a data link layer. So in that data link layer, there was many properties of it that we will see it. The position of data link layer, where we have a we are having a data link layer here. So we are having a that layer which is making that that is a physical layer, and that is a network layer. So data link layer is it in the middle of the these two layers. So what's the use of it? What's the properties, features of it? The data link layer we are having. The first feature is packetization. We will do a packet, making a packet of the data, and then after making a packet, then we will transfer it to a physical layer. So the data is coming from the network layer and going back to the physical layer. So and then this is that is medium access control. What we have to control any access medium control. We will use the data link layer. The addressing and error control and flow control. This is a features of the data link layer. That in the data link layer. So in this session, I will go for that this feature of the data link layer, that is a flow control here. So the flow control is a set of procedures used to restrict the amount of data that the sender can send before waiting for acknowledgement. We know that in a computer network, we are sending a data from the source to destination. So that data has to be sent into a flow, that the sender is sending and the receiver is not receiving at that speed. Then the data becomes overflow. Then the data becomes lost in the network. So we have to maintain a speed of absorption at the receiver side. So we have to maintain at the sender side also. So we have to restrict. We have to write any protocol. We have to have some control over the data. That is the sending of packet from the sender to receiver has to be that we will have to send the data, and accordingly that the receiver will receive the data. So our aim is to send the data properly from the source to destination. So these are the procedures which will we see in our lectures that we will follow in that thing. So we have protocols in this. We know that we are having two channels into it. We know that in the physical layer we have learned about the channels, that is noisy channel and noiseless channel. In noisy channel there was many things that will be come into a bandwidth, and it will make the data lost and make a data corrupt. But if we are having a noiseless channel, we are having a channel which is having no flow control or no error control into it, and we are having a no 100% data is sent from source to destination. There is no protocols into it. So that channel has to be is not a it is a reference channel. But in the scenario, in the present scenario, we will have a noisy channel according to it. So we will go for a noiseless channel, and then we will go for a noisy channel. What are the protocols we are using in noisy channels, and we are doing it. It is not a realistic channel because noiseless is not in real scenario. We will go for it, our noisy channel. So then noiseless channel, in noiseless channel we will assume that there is no frame lost, no duplicacy, no corrupted of packets into it. So we will develop a two algorithm of it, that protocol of it, simplest protocol and stop and wait protocol. In a simplest protocol, what we are having is we will send this is a design of there was no flow control and no error control into it. So we are having a sender side and a receiver side also. We will get a data from a network layer, because we know that we are having a 5 layers, that is transport layer, that is application layer, and we are having a network layer, then we are having a data link layer, and this is a physical layer. The data is coming from a center side. It will coming from a that is our transport layer and going to a receiver side at a transport layer. So it will making that the data has to be adding something is adding on every layer. So that is becomes a packet here. So the data is coming from, and then in the data link layer we were having a adder added here, and then after we will send a packet to physical layer. The physical layer media has sent our data from the data frames we will send, and then after at the receiver side, it will receive the frame and then it will pass it on to the transport layer. So it will from up to down here in the sender side and from down to up at the receiver side we are having. So we will make a request from a network and then repeat forever algorithm from the sender side, and then after we will have a notification from a physical side, and there was an algorithm on the receiver side, and then there this is a simplest protocols where we have a no flow and no error control. There is no duplication, there is no corrupted data or lost data here. So we will save a flow graph, that is flow diagram of this. At the sender side we will send our data frame and then it is a arrival there. We are sending our data and this is a arrival layer. We are sending a data, we are arrival there. So we have not received any acknowledgement, no acknowledgement here. So we are having no acknowledgement here. So in that we are having that what we are sending, the receiver is receiving. What we are sending, receiver is receiving. So no acknowledgement. So at any time, for example, 0.01 second, they will sending a this packet. It will receiving at 2 seconds. After 0.2 seconds. So at 3 seconds, it is sending other packet. It will receiving at 0.5 second. It will enrich. So there is no loss of packet. I'm saying that because it's a noiseless channel. So we are saying that there's no loss. So there's no loss of packets here. So we don't have to any check at the receiver side or sender side, any frames checking, any acknowledgement checking. So there is no checking of that because this is the simplest protocols we can use into a noisy channel. So this is a flow diagram of the simplest protocol. And then the second one is the stop and wait protocol. In stop and wait, what we have is stop and then wait for the acknowledgement. Stop and wait for the acknowledgement. So the design of this is when we are having a data, get a data from the network layer, and then after send a frame. The frames will be sent into a physical layer, and then after these sent to a received to a physical layer at the receiver side. It will deliver a data there. Then after it will, I am saying that we have to stop. We have to stop and wait for the acknowledgement. So then after, when the data is delivered to the receiver, it will send a frame as an acknowledgement frame that I have received your data, and then after it is okay, it is not corrupted or it's not lost. I'm acknowledging it. So it was acknowledging it data, and then after we will at the sender side we will saying that, oh, my data is received, fine, okay, now I will send the next frame to it. Okay, so it was requesting, event is to request from the network layer, and this is we have an algorithm at the region side, notify that and then after repeat on the sender side also, receiver side also. So we are having a communication from the sender to receiver and receiver to sender, both the side we are having, because at the sender they are sending the frames, at the receiver they are sending the acknowledgement to it. So we are having the flow diagram of it. So at the sender side we are having the frames that is arrived, okay, then it will send you the acknowledgement of it at the arrival. Then arrival of this, it will send the other frame, second frame. For maybe it is 0 frame, it is first frame, it is sending the acknowledge. At the time they are having they will sending a they are sending a graph frame, and then after they are receiving an acknowledgement. So this is stop and wait in a noiseless channel. Because it's not a real scenario, we will have to make a noisy channels. We in the real time scenario we are having a noisy channels, so we have to make a real time protocols which will use here. That is a stop and wait automatic repeat request, ARQ we are having there. Automatic request, go and back, and selective repeat, automatic repeat request. We have 3 algorithms which we are using here. That is in a noisy channel in which we are having the data will be lost, the acknowledgement will be lost, the data will be also corrupted, everything will be there in this channel we are with. So we have to make a error control also or flow control also. So in this channel we have to make a error control also and flow control also, because we the data have to be corrupted, because we are sending a data into a noisy channel, the data will be corrupted also. So we get to know at the receiver side the data is corrupted, you will discard it, so you will say it. Flow control also, because the data, the rate of sending a data and the rate of absorption at the data receiver side has to be maintained, that the data is not to be lost in that thing. So the error correction in stop and wait. First one is my stop and wait automatic request, repeat request, and the error correction in a stop and wait request is done as a copy of sent data and retransmitted at the data expires. As the timer expires, what we are having in the solution at the noisy channel, we are making that the when we are sending a data, we will have a timer of 2 seconds, 3 seconds, 4 seconds. What the thing is, we are just maintaining a timer. If the timer expires, at the timer we are not getting an acknowledgement of it. We are not getting a acknowledgement. We are not getting a you can say is also a frame of it. Then we will retransmit it, because the data may be lost also. The maybe so we have to be retransmitted. The copy has to be retransmitted. We are making a copies of frames. If frame 0 is sending and it get lost into a network, then we are making a copy of it, and we will make a to have to retransmit the data, and then the timer before the timer have expired, when the timer expired, then after we have to retransmit it. So in a stop and wait ARQ, we have a sequence number of it, because when we are having a data, when we are having a data, and then data has to be frame number has to be a sequence number. So we are having a number sequence. It is a modulus of modulus 2. So we are having 0, 1 as a frame number, 0 and 1 as a arithmetic frame numbers. In a stop and wait, we are acknowledgement also in a mod mention. So we are having a frame number 0 and 1, and in also this we are having acknowledgement 0 and 1. We are having acknowledgement 0 and 1. We are accepted. If we are giving a frame 0, we are accepting that the acknowledgement 1. If I am sending a frame 1, and we are accepting a acknowledgement 0 in that. So we are like this. We are have to this. The frame 0 sending, then we have a +1 acknowledgement we are having. So if we are having a frame 1, we have to go for a acknowledgement 0. So vice versa, we will do it. So this is a design of stop and wait ARQ protocol. In the stop and wait, we are a frame, that frame SN, which we have to send a next. Then after in the network layer, we will have a sequence number here. So we will get a sequence number and the frame number. Then we have to get data. That the data will be added to a data link layer, and then after send a packet to a network, and then after the packet is received and delivered to it. Because it is a noisy channel, we have a cases of lost in duplicacy and corrupted data. Then we will go for a acknowledgement. If the data acknowledgement, and then after the data is received to a field zone, then the data is received for the this. If it's not received, then after mention. But the one thing more which we are having is time out. We are having a timer which is having, when we send a data into a network, and then after up to that time we are not receiving any acknowledgement or any response of it, we will if the timer expires, so we will retransmit it. So up to this this expires, so we will have to retransmit it. We have to make a retransmit of that data. So that is the request from the network layer, and then the network layer we will having a sending, and the notification for the physical layer, it will sending into a network, and then after notifying into a physical layer we are having a that the algorithm which we are having a receiver, and then after we are making that thing. Next, this is a flow diagram of the stop and wait we are having. The stop and wait, we are having a sender side also, receiver side also. This is a frames with what we have to send. So I have said it ki the frames will be 0s and 1, and at the receiver side also the same is 0s and 1s. So this is a SN packet have to send it. The frame 0 has to be sent, and that is received in there. So there is a one packet send, one frame send and one frame receive. So 1 we are having. So that the 0 is frame is sent to a network, and then after it is received to a network, and then we are have a acknowledgement of that is frame plus 1, that is a 1. Then after we are aware of this, then after we have to send it, and the timer is also there. So if we are having a timer, before timer that data is come, or that the frame is come from the sender to receiver side, then we will have a stop the timer. If that is stop the timer, and then after a next frame has to be sent, so that frame has to be requesting other next value of that. The next value, that is frame is lost. Maybe any failure in the network, any link failure, where you can say it, any down in the network, any router problem, any problem in the network, and then after that is lost into a network. So we are having a timer counter which is active at the sender side. It is saying that okay, now the timer is out. So what we have to do is we have to make that sure that the acknowledgement is not there, because at the receiver side the data is not received. So why the receiver will give a acknowledgement of it? So what they will do, if the timeout is gone, the timer is have to restart again. So it will say that okay, some problem has to be there, the data has been lost into a network, so we have to resend it. That is retransmit the packet, and then after it will go there. So at the time we will receive a packet frame 1 and the frame will received, and then we will give a acknowledgement of 0. So the timer will be stopped. So this is a cycle which is coming to a at the sender side is giving a packet, and the packet will be lost into it. So there was 2 cases into it. When the sender has been, the frame is lost. The frame is lost. Or at the receiver side, what the thing is, receiver side we are having the acknowledgement is lost. So there was 2 cases we are having here, is sender is lost and receivers is lost. So at the sender we are having a frame loss, at the receiver we are having acknowledgement loss. So at the sender we are having a frame lost here case also, and at the when the third packet will send, third frame will send, that is a 0. The frame 0 will send from here to here, and then after it is received at the receiver side, and it will sending the acknowledgement sending. Then what we have to do is the acknowledgement sending, the acknowledgement is lost. So what the acknowledgement is lost, when the acknowledgement is lost, what we have to do is we have to be a counter that is started on the when we send a packet, when we send any frame at the receiver side, sender side, we have started a point timer. That timer, if it's not receiving any acknowledgement of it, so it will see that my packet is lost, or acknowledgement is lost, something is lost. So it will have to retransmit the packets again, and then after it will making a arrival and then making a acknowledgement of it. In a stop and wait, everything has to be, we have to send a packet, we are having a timer of it at the sender side. If its timer get over, we will have to retransmit. Either of the cases, if the frame is lost or the you can say is acknowledgement loss. So this is a stop and wait window. The next protocol is to be go back n protocol. The sequence number of this is 2 raised to power m. For example, I am having a 3-bit fill. So what are the 2 raised to power 3? That is 8. You will have a 0 to 7 bits you can use into a frames. 1 to 3 to 7 we can use it as a frame numbers we can use it as. So this is a sender window from the go back n AKGEC, and this is a before and after sliding. Okay, then we are using a slide window here also, slide window concept also. The slide window concept is a abstract concept. Slide window is a concept defining imaginary box we are having. It's a size of 2 raised to power 2m minus 1. So if m is a bit which we are using here, so we are using 2 raised to power m, that is 2 raised to power 3. We are having 8 bits, so we will use at 7. So that is 0 to 7 bits we will use as an window. This is m minus 1, that is 7 matlab 6 windows. 0 to 6 ki you can use a sender window. If we are having this like 1, 2, 3, 4, 5, 6, 7 up to 7 will have a packets, because there are 8 packets we are having. So window has to be 1 minus of it. So it will the window will be like this. -1 we are which have a, this window have to be sent from the source side to destination type. So we are m bit we are having 2 raised to power m, 2 raised to power m a sequence number, and 2 raised to power m minus 1 we are having a window size. So 3 bit we are having a 8, what way 8 is, that 8 is to be a sequence number, and 0 to 8 minus 1, that is 7, is my, what we are having is sliding send window, yes, sliding window, you can say it, sliding window size. Okay, so this is a size what we are using this in these 2 algorithms. In the next selective repeat, or in this algorithm go back, and we are having one more term, that is sliding window we are using, in which we are having a number of frames. So -1, that the size of the sliding window here. So this is a send window for the go back and ARQ. We are having this packets, we are having up to 15 frames we are having. So matlab 2 raised to power 4 we are having, 16 we are having, so 0 to 16 we are having. So 16, 15 minus 14, 14 is, this is my sequence number, and 14 is my sliding window ka size, window size. Okay, sliding window size, what we are having. So we are having a sender window which is used here. So we are having this packets, this much packet, this is acknowledgement, already we are having acknowledged that packet has received in the receiver side. But this packet, this window, we are have to send the message, that is frames are sent, but not acknowledgement received from it. Matlab they are outstanding into it. Then this is a SM, this is the first SF key, and this is SN, the last one. So this is the size of this 2 raised to power m minus 1. This is a size. This is a window frame that has been sent, that can be sent and but not received from the upper layer. These frames are receiving from the upper layers. Upper layer that is a network layer. They will make it a packet, and then they have to go to a data link layer. They will make it a frame of it. So the frame has not been sent and not received from the upper layer. Upper layer is a network layer. Okay, and these frames that can't be sent because they are not in a picture right now. Okay, so this is before sliding a send window, that is a window sliding window side. So but when we have these acknowledgement received, so we have to slide a window. So next sliding is this. So we will slide a window up to this, and then after we will send the others packet also. So the window will slide when the data is received, and the acknowledgement we will get, we will say that the data is received. So we will slide a window towards the next one, that is the frames that is not sent. So it will send, and then after we will go for other. Then we go for this. So the frames are sent according to it. Okay. Next we are having a go back of this. We are having a slide window. We can say in send window, we can slide one more slot with valid acknowledgement. When we get acknowledgement, then after we will slide a window. Otherwise, we will not slide a window. We will retransmit the window. Okay, so this is a receiver window for the go back, in which we will receive. It will receive only one frame at a time. They are having, sender is having a window of it. They are sending 1, 1, 1, 1, 1. They are having, for example, M is 4, so they are saving 0 to 14 frames to it, and then getting an acknowledgement of it. They are having window of it. But at the receiver side, they are only one pair that they are receiving only one. So that is only if the frames already received and acknowledged. If this is received or these acknowledgement frame have not received until the window will slide. So one, then after this one, this with this. At the receiver side, that is only 1, 1, 1, 1. It will go for like this. At the and then it will go for sliding. It will go for 4 also. So at the sender side also, at the sender side what we are having a sliding window at the sender side. So this is a slide window at the sender side, but the receiver side, this is not a window there. We are having only one receiver, that is only one frame is received at that time. So a receive side is the abstract imaginary box of size of 1. So at the sender side, what the value of sliding window is 2 raised to power m minus 1, where the m are the bits. At the receiver side, what the value of it is? Only 1 we are having. The window size is only 1 at the receiver side, but at the sender side it is 2 raised to power m minus 1. So at the sender side it is a correct frame is received, then after it will go at the next frame to get acknowledgement of it, otherwise it will not go unto this. So this is a design of go back N ARQ. ARQ, we are having a this is a data, we have to send it, get data from it, send our data from, and we will get a receiver packet, and then after receive it, the data is really, then we have to go our acknowledgement of it, then the acknowledgement is going to that sender side. Okay, next we have a request of network layer, then after we have a algorithm protocols. According to it, we will have a time counter, time expires, time counter also there into a go back and also. So what we are having a window size. So what we are making that if the window size is less than 2 raised to power m, for example, m key value you can make it 2. So 2 raised to power m is 4. So that is a window size that is 4 say less than, that is if you are making a window size of maybe 3, not 4, less than 3. So what will happen? Making a less than 4 or equals to 4. So what will happen in that? So if we are making a size of window is 3, if we are sending frame 0, the acknowledgement is lost. If I am sending the frame 1, acknowledgement is lost. If I am sending the frame 2, acknowledgement is lost. If I am saying, and the time will get out for the 0 to get an acknowledgement of it, because I am sending a 0 packet and we have to make that at this. So what we are expecting is to be making a packet 3, but it will retransmit it because the timer expire, and so you have to retransmit at 0. So I have correctly discarded. Okay, but if it's equals to 4, what will happen? Then the window size is 4. So we will send a frame 0, it will discard it. If we send a frame 1, it will discard it. If sending 2, discard it. If we are sending 3, discard it. And if because it's timeout, we have to resend it the frame 0. It become an enormous error into accepted errorly, because they are accepting because this 0 they are not expecting, this frame they are accepting, but they are making that confusion that oh, frame 0 is accepted because they are retransmitted. Oh, this not retransmitted because we have to retransmit this frame 0 first, because that the timer expired and we are not getting the acknowledgement of it. So that's the thing, not the thing to making a window size of 2 raised to power m. So we are making a less than that, that is 2 raised to power m minus 1 window size to be perfect to make it. That's why we are making a 2 raised to power m minus 1 the window size what we are having here. So go back, and the size of the sender window is less than 2 raised to power n, and the size of the receiver is to be 1. So we are, this is 1 or this is 2 raised to power m minus 1, this is the size of it. Okay, this is a flow diagram for the go back N ARQ, that is at the sender side what we are having is, so we are having a 7, we are making it 2 0 to 6. 2 raised to power m minus 1. This is a size 3-bit that is 8. So 0 to 7 we are making for the sequence number, and 0 to 6 we are making for the the thing. So this is a timer which is when we are sending a frame 0. So we will sending a frame 0, we will getting a frame 0, and then after acknowledgement of this. Then we are sending a frame 1, requesting for frame 1. Then after the frame 1 will get discarded. Frame acknowledgement is get lost into a network. The situation is to be, then frame that frame is to be there, and then after we are sending a second frame here, and then after we are getting not getting a then we are getting a at, when we are sending the third frame, after that we are getting a frame 3 request, and then after we are getting a third, and then we are getting, but we are not getting a request of frame first into it. So we know that only one received, 2, 3, and this received, this received, this received, but this will not receive because the acknowledgement is not getting mentioned. We have a timer out because this window will shift to the window will shift from 0 to 6 to next 7012 because it is a size of 6, but it will say that this frame is not sent, you have to retransmit it. So what we have to do is, if what the case is in the flow graph, if we are having a 0, we have an acknowledgement of this. If this frame is lost, so what we have to say, if this frame, but that frame is not making. So in a go back and we have to go at previous situation when the data is not sent. So if 1, 2 and 3 will, this not is sent, this send, we have to retransmit this. So we have to retransmit and retransmit it. So we have to retransmit the second or third because it is received, but we have to go back up to n, the data is lost, and then after we have to retransmit it, this is packet is gone, we have to waiting for acknowledgement, but no, we have to retransmit all these packets that is sent before it, and then after we are making that thing. So that this is the advantage of that. When we are having any loss in a packet into a network, then we have to retransmit and go back to that situation, and then after retransmit it back. So that's in the last protocol which we are using is the size of this is stop and wait, and the go is only a 1 size. Then we have a selective repeat. This is the last protocol which is using into our noisy network. This is when we are have to send a this is frames are sent, and we have to send the acknowledgement. The size is 2 raised to power m-1, and the frame has to be sent, and these frames are not being sent because they are not received from the upper layer. So these are the receiver side. In this, we are having a window on both the sides. So we are having a receiver window also, and but in go back end we are not having, only one at the receiver, and there was a window at sender. So in the both sides, sender or receiver, they are having a window size of it. Okay, so we are expecting that 2 raised to power m at also a receiver side window. So we are having a design of it, and then after we are sending a frames on, then frames has to be this, and we are having a deliver a letter. This frame has to be, this sliding window has to be sent from this side, and then the receiver will receive, and that has to be from the receive. They are having also a window of it. Then after send to a receiver, this is an acknowledgement. There were 2 terms here, AKGEC, that is acknowledgement number, N key, that is not acknowledgement. We are not getting that acknowledgement. NAK, they are giving it extra thing here. This also having a timer and request for the timer, and then after notify the physical timer, and then after we will give a restrict to it. Okay. The selective repeat ARQ window, in this we are having a size, size we have to make it. So that is correctly discharge or this. So what we have, if it is equals to 2 raised to power m, up to equals to what we are having is, when we are giving a frame 0, it is discarding it, not having acknowledgement of it. Frame 1, we are having a not getting acknowledgement. Then we have to resend the 0 back. We have to resend because that is correctly discarded, that the frame is not, has to be sent, or we have to send it back the correct frame. So what way is frame 0 is sending either, and we are not getting the acknowledgement. Frame 1 is sending, not getting the 2 is sending, and then 0 is sending because, but we are accepting that there will be a 3 because the window size is greater than 2 raised to power m-1. We don't have to make that 2 raised to power m because it will giving a error message, or error we expect is accepting there. So that does not follow. So that this window size 2 raised to power m saying it is greater than that, not is accepted. This is accepted in the go back selective repeat R. So in the selective repeat, the size of the sender sign is almost 2 raised to power m-1. At the sender side or receiver side, if m are the bits which we are using, and m 2 raised to power m, that is 8. At the 8 receiver side, so we are making at most 4 at this 4, so 0 1 2 3. This is the size of a window. We can make it at sender or receiver, right? Both will be same. If we are making a 2 sliding window side as a sender side and 2 at the receiver side, both the sides you have to be same at the receiver or sender side. So delivery at the before and after, what we have to do is in the selective repeat, this, what is the disadvantage of what the previous one is, go back on. What we is this, कि if we are having 0, 1, 2, 3, 4, 5, 6, 7, if this packet sent, this packet sent, this packet sent, this packet sent, all these packets sent, but this packet was not sent, lost in the network, any problem with this. So what we have to go back is, we have to retransmit all the packets which is after that packet. These are received, but we have to go it back at the situation and then after repeat that process to retransmit it. But this is not a good approach, na? Because these second, third, fourth, up to 7 packet will be sent. Then after, why to make it this extra effort to make it this whole retransmission? What we have to do is, that is a selective repeat. What the advantage, what is the disadvantage of it? It will making a thing that if this is not received, so it will repeat this is called selective repeat, what we are having here. So we will selectively repeat it and then after only send this packet to the back, and or second, third and fourth, fifth, sixth, 7 packets has to be sent. So this is what is the disadvantage of going back is overcome by the selective repeat ARQ. So in this we are having a delivery. Before delivery, we are having that CN receiver side ki we are having 0, 1, 2, 3 packets, 3 and 4. If this packet is not sent, we are getting an acknowledgement of this. If this packets are not sent, so 3 and 4 only will receive, 4 and 5 is received. So we have not sent it back. So only 3 and 4 just which is lost, we have to send it back. Only then those packets, only that frames has to be sent it out. So this is a flow graph of this is flow graph of this, so which is having it if we are sending a frame 0 and we will getting an acknowledgement of that. If we are giving a frame 1, what was the frame 1? That is lost in a packet. So we are having that frame 2, okay, but it is saying that I have to get only concept, which packet we have to get is frame 1, but I'm not getting a frame 1, I'm getting a frame 2. So it will sending a negative acknowledgement of this. So okay, then they are saying, okay, that is not sent, so I will send it after 3, we will send it the feedback. So we are having a positive acknowledgement also, negative acknowledgement also. If it is not, but in the previous other protocols, they are not giving they are only giving the positive acknowledgement. They are not giving a negative acknowledgement, but in this selective repeat, they are giving a positive, negative acknowledgement also, NAK, and they are sending it, if this packet is not received, so they are saying this packet is not received, this is having a negative acknowledgement, please resend it then. So for what is frame 0 timer is this, frame 1 timer is this, it has to resend it and then after making it that timers here. This is a frame 2 timer and this is frame 3 timer. Up to frame timer, they will accept that they will get a positive also. So they will, in the selective, they will get a positive also or negative acknowledgement, both they will get. If they will not receive the packet, they will say that, and if they receive the packet, they will get to know about this. So this is one of the efficient protocols which is used in Noisy. That is a selective repeat ARQ, where we are having any problem with when we are sending a data from a data link layer to the receiver side, we will get to know that the data has to be sent properly to the making that flow into a network. So that flow is to be goted by this selective repeat ARQ, and this selective repeat ARQ we are having in our course, and this is one of the important advantage of it, which is the drawback of go back again when we have to select any number. If for example we are having, for example 5, 6, 7 packets with this. For example, this packet send, this packet send, this packet send, this packet send. This is not sent. So okay, so they will selectively get a negative acknowledgement of 1, 3, 5 and 7. All this having a negative acknowledgement of 1, you can 3 and 5 and 7. They will get a negative acknowledgement, and then they will say that okay, this packet is not received, fine, we will resend it. So the disadvantage of go back and is overcome by the selective repeat ARQ, and having an advantage that only that packet that has been sent is to be making that packet has to be resended, and then after we will delivered it. So this is the popular protocol which is used in the noisy channels. Thank you.